Aggregative properties, and emergent properties. Written and narrated by J.M. KUCZYNSKI, Ph.D. An aggregative property is one that is had by pluralities of objects, but is absent from any given one of those objects. An example is temperature. An object's temperature is proportional to the mean kinetic energy of the molecules composing it, and temperature is therefore a property of systems of interacting molecules. The property of being 78 degrees is the property, had by such a system, of having a certain mean kinetic energy. Given that temperature is a property of systems of interacting particles, no one particle has a temperature. An emergent property is a property of systems of events whose existence cannot be deduced from what is known about those events when taken in isolation. For example, given a class of objects, each of which has a low degree of thermal conductivity, it may happen that when those objects are assembled in a certain way, the resulting structure has a high degree of thermal conductivity. To take another example, given a class of objects, each of which is brittle, it may happen that when those objects are assembled in a certain way, the resulting structure is extremely resilient. To take a more counterintuitive and substantial example, given two rocks, each of which weighs exactly 1 pound, if we place the one rock on top of the other, the resulting structure weighs not 2 pounds, but just slightly over 2 pounds. A consequence of relativity theory is that mass is non-additive, meaning that the mass of a given object is not the arithmetical sum of the masses of its constituents. Thus, relative to what was known before relativity theory, masses of object pluralities were emergent with respect to the masses of their constituent objects. In other words, the mass of a given object plurality could not be deduced from the masses of the objects composing it. A related consequence of relativity theory is that length is non-additive, meaning that the length of a straight object is not the arithmetical sum of the lengths of its segments. Let X be a straight, rigid steel rod with a length of at least 2.5 yards, and let alpha and beta be the first and second yard-long segments of X. The segment of X that consists of alpha and beta is not 2 yards, but just slightly over 2 yards. Thus, relative to what was known before relativity theory, the length of a given object was emergent with respect to the lengths of its segments. In other words, the length of a given object could not be deduced from the lengths of its segments.
Sample complete. Ready to continue?